Okay, this is the second video, or part 2, for section 4.4, adding, subtracting, and graphing polynomials. Okay, so in the last section we actually learned a few things. The last thing we did, we learned how to graph polynomials basically just by plotting points. And then what we did is we talked about the terms of polynomials, the coefficient of each term, the degree of each term, and the degree of the overall polynomial. And then we also talked about evaluating polynomials at a specific value. Okay? And remember, polynomials could either be a multivariable polynomial, excuse me, which has two or three or more variables within that polynomial, and we learned all those things in the last video in part 1. So now what we're going to do is we're going to learn how to add and subtract polynomials, which is actually very simple. Okay, so the first thing that I want to mention is that you can only add or subtract like terms of a polynomial. You can only add or subtract like terms of a polynomial. Okay? Well, what is a like term? So let me write this down. A like term has the same variable, okay, raised to the same exponent. Okay, a like term has the same variable raised to the same exponent. So let's go ahead and take a look at some like terms. So let's say we have, for example, 3x squared minus 2x squared, 7x squared. Okay, these are all like terms. All right? Why are they like terms? Well, like it says, has the same variable, so these all have the variable x, and they're all raised to, that is, the variable is all raised to the second power. Okay? This could also be for multivariables. So we might have, let's say, 7xy cubed minus 4xy cubed. All right? These are like terms. Why? Because you have an x raised to the first power. You have a y raised to the third power. Okay? Those are like terms. All right? Unlike terms, so basically that's pretty easy. So let's look at, for example, 2x squared y, 3x squared, and 4x squared. Okay? Are these like terms? No. These are not like terms because there's a y here and there's no y here or here. Okay? Let's look at this one. 5x to the fourth power, 3x squared, and 5x. Well, these are not like. Again, because you have the power is different on all of these variables. There's like a 1 there, right? So the x is okay. All right? They're all consistent. They have the same variable x, but the powers are different. So just go back to this basic definition. A like term has the same variable raised to the same exponent. Simple as that. And you can only add or subtract like terms of a polynomial. All right? So once you know that, it's just very simple. So let's go ahead and work out some problems. So let's go ahead and add. All right? Now there's two different ways you can add polynomials together. You can add them horizontally or vertically. Well, what's the difference between the two? Let's look at a simple example. Let's just say if I was to add 2 plus 2, this is adding the numbers horizontally, which is just 4. Well, vertically would be 2 plus 2, like that, and that would be 4. Okay? So for polynomials, it's the same thing. The preferred method, excuse me, the preferred method, I would say, is to do it horizontally. Once you get more advanced in your mathematics, you're not going to be adding or subtracting things vertically. Okay? But I'll show you both methods, but you want to try to just do it horizontally. Okay? So let's go ahead and look at this. 3x squared plus 2x subtract 4, and I'll put parentheses around this, added to, and parentheses around this polynomial, minus 5x squared plus 7x plus 1. Okay? So we're going to add this horizontally. So remember, you're only going to add the terms that are like. So let me just highlight these in color. Well, like term, like term, like term, like term, and like term, and like term. So we'll add the yellows, we'll add the blues, we'll add the greens. So basically what we have, this equals, so if you just look at the coefficients, well, what's 3 added to negative 5? Well, that's going to be negative 2. And then your variable is x raised to the second power. So basically 3x squared added to minus 5x squared is a minus 2x squared. Okay, that was these two right here. Now let's go ahead and add these two. So 2x added to 7x. Well, 2 plus 7 is 9. And then we have our variable x. Okay, then finally we'll add the constants, these right here. Negative 4 added to 1 is negative 3. So you can just put subtract 3. And this is our result. Okay? Now, let's say I wanted to do this vertically. Again, I'm just going to show you this technique, but I would go ahead and just go ahead and add and subtract horizontally. Okay? So let's do this. We'd have 3x squared plus 2x subtract 4. And then we're going to add this. And then we're just going to line up the like terms. So this is minus 5x squared plus 7x plus 1. All right? So we'll just look at these vertically, right? These are all like terms that are just lined up. So 3x squared added to minus 5x squared, that's going to be a negative 2x squared. Then we add 2x plus 7x, that's 9x. And then negative 4 plus 1 is negative 3. So you get the same result, it's just a different way to approach it. So this was adding vertically. And again, I don't prefer this method. Like I said, you should just start getting used to adding things horizontally. Okay? All right, so let's go ahead and do another example. Okay, so let's say I have something like this. Let's go 5x cubed minus 3x plus 4. And let's add that to 7x to the 4th power plus 3x squared minus 1, let's say. Okay? Well, let's do the color coding here again just to show you. So here we have a 5x squared and a 3x squared. So those are like terms, right? And then we also have a 4 and a negative 1. Those are like terms. Now, there are no other like terms here, okay? This minus 3x, there is no x term on the right hand side over here in parentheses. And 7x to the 4th, there is nothing in the left-hand parentheses that are like. So as all you can do is just add your like terms. So what's 5x squared added to 3x squared? Well, that's going to be 8x squared. Okay? And then let's go ahead and just write down, just bring this down. Subtract 3x. That's all you can do to it, right? And then let's go ahead and bring this down right here, plus 7x to the 4th. Okay? And then we'll combine the 4 added to negative 1, that's going to be 3. Okay? Now, the last thing that I want to mention about polynomials, you want to write your final result in descending order. What does that mean? Descending means that you're going to write from the largest degree to the smallest degree term. Okay, the largest degree term to the smallest degree term. So that means the largest exponent to the smallest exponent. Okay? So largest exponent to smallest exponent. All right. Now, if it was multivariable, remember you have to add the exponents together when you have a multivariable polynomial. And we'll do one of those in a little bit. So if we look at this final result right here, what's the largest exponent? Well, x to the 4th. So we'll write this as 7x to the 4th. That will be the first one. Okay. Then we have the next largest one is x squared. So that's plus 8x squared. Then the next largest one is just x to the 1st power. So that's minus 3x. And then finally, our constant is going to be last. So this is written in descending order. Notice it goes 4, then 2, then 1, and then a 0 degree term right here. All right? Okay. Let's do one with a multivariable, and then we'll get into subtracting. So let's say we have 3x squared y plus 2y squared added to, let's say we have negative 10x squared y plus 2y minus 4y squared. Or actually, let's change this around a little bit. Let me write this as 2y cubed minus 3y squared. Let's do that. Okay? So let's identify our like terms. So we have a 3x squared y and an x squared y here, or a minus 10x squared y. So these are like terms, right? The x squared y. Then we have a y squared term right there. Okay? And then that's the only ones that are like. So if we just go ahead and add those together, 3x squared y added to minus 10x squared y, that's going to be a minus 7x squared y, right? And usually what I'll do too, I haven't been doing it, is usually mark the ones off that I've finished working with. I haven't been doing it because I've color-coded them, but when you don't have this option, not carrying around your colored pencils or colored markers and so on, just go ahead and cross out the ones that you finished working with. And sometimes what I do is I'll do a single underline and a single underline to note that those are like, or I'll do a double underline and a double underline here noting those are like. Okay? So if you're not using color, you could use the single or double underline or even triple underline and so on. Okay? So I added those two together. Then the y squareds, well, it's 2y squared added to minus 3y squared, so that's a minus y squared. So I finished those. And then the last one is 2y cubed. No like terms for that. Now let's see. This excuse me. This is an interesting one because we want to write this in descending order. So you might think, well, the largest exponent here is 3, but it's not. Remember, there's a little 1 right here, and you have to add these together for multivariable. So this is actually a third degree term, and this is also a third degree term. So it really doesn't matter which one you write first. Okay? I'll just pick the one that's in multivariable first. So I'll write this as 7x squared y. Then I'll write the 2y cubed, and then finally the lowest degree is the squared term, so minus y squared. So this is written in descending order. So you might ask, well, is it wrong if I put this first? No, it's not. I mean, if you wanted to, you could write it as minus 2y cubed subtract 7x squared y minus y squared. Okay? That makes no difference. Okay, now let's go ahead and look at subtraction of polynomials. All right, same thing. Remember, like we did, we can only add or subtract polynomials that have like terms. Okay? So one rule that we're going to use, okay, is this. A subtract B. So imagine if A was a polynomial and B was a polynomial. I'm going to write this as A added to, because it's always easier to add, the opposite then of B. So what am I doing? I'm just saying, let's say, for example, 8 subtract 2. Looks like a B. So it's 8 subtract 2 equals 8 added to a negative 2. I should put parentheses around these here. Okay? And that's simply going to be 6, right? So for a polynomial, let's just say I have 5x minus 2 subtract 8x minus 5. All right? So this is kind of like your A, and this is like your B. So it says to take the A, just rewrite it, 5x minus 2. Then we're going to add that to the opposite of B. Well, what's the opposite of 8x? It's a minus 8x. What's the opposite of 5? Should get 5 there. Opposite of 5 is a plus 5. So I'm adding the opposite. Okay, I'm taking the opposite of what's in the parentheses right here. So an 8x becomes a negative 8x, a negative 5 becomes a plus 5, right? So now you're back to what we just did, adding. So the 5x added to minus 8x, all right, that's going to equal negative 3x, and then the negative 2 added to 5, that's going to be a plus 3. So this is the result. So you're just, when you subtract polynomials, you're just adding the opposite. Okay? Now I won't look at this subtraction vertically. I mean, you just line things up and then you subtract vertically. Okay? I'm going to concentrate on just doing these techniques horizontally. Okay? So let's go ahead and look at another one. Let's say we have negative 2x to the third power plus 4x minus 1, and then we're going to subtract 5x to the third power plus x squared minus 9. Okay? So let's do it this way. Where are the like terms? Well, we have an x cubed and an x cubed. Okay? We have a negative 1 and a negative 9. Okay? And then the rest of them are unlike. Okay? So the first thing that we're going to do is we're just going to add the opposite. So I just rewrite this completely. Minus 2x cubed plus 4x subtract 1. And we're going to add that to the opposite of what's in the parentheses. So the 5x cubed becomes a minus 5x cubed. Excuse me. The x squared becomes a minus x squared. And the negative 9 becomes a plus 9. All right? So this equals what? Okay, so remember, these are like terms here, and these are like terms right here. So what are we going to have? A minus 2x cubed and added to a minus 5x cubed. So that's going to be a minus 7x cubed. I'll just rewrite the 4x. Okay. And then I'll rewrite the negative x squared. Okay. And again, I'm going to cross out what I've worked with. Okay, so I've worked with that. And then the negative 1 added to 9, that's going to be a positive 8. We want to write this in descending order, so this term should become the second one in the polynomial. So minus 7x cubed subtract x squared plus 4x plus 8. So, descending order, 3, 2, 1, and then 0 power, right? You don't need to put that, but I'm just showing you again. That's really x to the 0. Because remember, anything to the 0 power is just 1. Okay? So that's really all there is to graphing, I'm sorry, not graphing, but adding and subtracting polynomials. You could have different, what all this is here, you could have different different types of scenarios. You could have more than more than 2 different polynomials. You can have 3. So let's do an example here. More than 2 polynomials. Okay, so let's say, for example, we want to do this. 3x cubed minus 2x squared plus 7x subtract 1, and then subtract 3x squared plus 4x minus 3, and then we'll add 7x squared plus 4. Okay? So let's just add left to right or subtract left to right. Okay, so if we look at just this right here, this is subtraction, so I'm going to add the opposite. So I'll write this as 3x cubed subtract 2x squared plus 7x subtract 1 added to the opposite, so that's minus 3x squared minus 4x plus 3, okay? And then I'll just bring this down, plus 7x squared plus 4. Alright? There's all these marks. I don't know where they came from. Okay, so here we go. We have a 3x cubed. Is there a x cubed over in the second polynomial? No. So I'll just write this as 3x cubed. I'll mark it off that I've worked with it. Then we have, like terms here, a minus 2x squared and a minus 3x squared. That's going to be a minus 5x squared. I'll mark those off. Then a plus 7x added to a minus 4x. That's going to be 3x. So I'll mark those off. And then negative 1 added to 3. That's going to be a plus 2. Okay, so I now have this polynomial. And then just bring this down. So it's plus 7x squared plus 4. Okay? Again, there are no x cubed terms, so this is just 3x cubed. I work with that, cross it out. A minus 5x squared and a plus 7x squared is going to be a positive 2x squared. So I worked with those, cross them out. There is no x term in the second polynomial, so I'll just write this as plus 3x. So I finish that. And then plus 2 plus 4 is plus 6. Okay? So the final result is 3x cubed plus 2x squared plus 3x plus 6. Now I'll ask you, is this in descending order, this polynomial? Yes, it is. Why? Because we have the highest to the lowest exponent. Okay? Excuse me. No idea where all these markings came from. I'm just erasing them. Alright. Okay. Let's do one more. Let's do a multivariable example. So let's say we have 4a squared bc plus 3a squared bc squared minus 7a squared b subtract 5a squared bc minus 8a squared bc squared plus a squared b squared, and let's go plus 15a squared b squared. Okay, so here's three things going on: subtraction and addition, right? So for this subtraction, remember we are going to write this as adding the opposite. So this is going to equal, rewrite, I'm just going to rewrite all this. Then adding the opposite. Minus, right? Then a plus 8a squared bc squared, and then a minus a squared b squared, and then our last term, let's bring that down, 15a squared b squared. Okay? Alright, now let's see, we need to identify like terms. So a squared bc, so these are actually like terms right here. So let's deal with those two first. So we have 4 of them added to a negative 5 of them. That means it's going to be a negative 1 of them. I don't have to put the 1, so I'll just put a minus a squared bc. Okay? So finish that. Let's see. Then we have an a squared bc squared. A squared bc squared. Okay, these happen to be like right here. So 3 of them and 8 of them is going to give me 11 of them, and those thems are the a squared bc squared, right? So that goes out. And then a squared b, and this says a squared b squared over here on the right. So that's all the like terms we have. So I'm just going to rewrite this, minus 7a squared b, and then minus a squared b squared. Okay. Put those in parentheses, and I'm just going to add this to 15a squared b squared. Okay, well the only thing that's like here is this one and this one, right? So, whoops, I made a mistake here. Go back for a second. Sorry about that. Or did I? No mistake. Okay, no, we're good. I was looking at something wrong here. Okay, so now, where are we at? Oh yeah, we're going to combine these two together. Alright, so finally, clean this up. I don't know where these little lines are coming from. Alright, so what do we have as our final result? Negative a squared bc plus 11a squared bc squared minus 7a squared b, and then the negative 1 added to 15 is going to be a 14a squared b squared. Now, this is where we need to figure out how to write this in descending order. So we want to just get the degree of each term. So this is like a first power, this is like a first power, this is like a first power, and that's it. So remember, we add the exponents. So this is actually a 4th degree term. Add the exponents. This is a 5th degree term. Add the exponents. This is a 3rd degree term. And add the exponents. This is a 4th degree term. So we want to go in descending order, so we want to go 5th, 4th, and 3rd. All right? So we have to write this one first, 11a squared bc squared. Okay? Now the 4th degree, there's no priority here, so I'll just write minus a squared bc, and then plus 14a squared b squared. All right? So I took care of this one, and this one, and this one. And then our last one is the 3rd degree term, so that's a negative. There we go. A negative 7a squared b. Okay? So this is written in descending order, and that would be the final result. All right. Okay. That concludes then this section, which is 4.4. And the next section in 4.5, we're going to start multiplying polynomials, and then we'll get into some special multiplication type problems. They call those special products, and that's in 4.6. All right, I hope you guys are doing well, and I'll go ahead and get these videos posted here in the next day or so.